This video is a continuation of constitutional isomers and will focus on calculating the degree of unsaturation. A useful approach to know what kind of isomers you need to draw is by calculating the degree of unsaturation. This becomes glaringly obvious when you come across a molecule that requires a double bond or a ring or something of that sort. So how do we calculate the degree of unsaturation? Well, we must use this following equation. When we are given a chemical formula, all we do is take the number of each element and put it into this equation. If the corresponding element is not present in your chemical formula, then you can just ignore it. Whilst if there are elements present in your chemical formula that are not part of this calculation, you just ignore it. Here, let's try this one out. C5H12. The degree of unsaturation will equal 2 times 5 plus 2 plus 0 minus 0 minus 12 all divided by 2, which in the end equals 0. What this tells us is C5H12 is a saturated molecule. All of the possible carbon-hydrogen bonds have been formed. You may have heard this term before when talking about saturated and unsaturated fats. Well, now we know. Let's do another one. C2H5N. The du equals 2 times 2 plus 2 plus 1 minus 0 minus 5 all divided by 2. So in this case, du equals 2 over 2, which equals 1. So this molecule has a degree of unsaturation equal to 1. There must be a double bond or a ring within this molecule. So just to emphasize what the degree of unsaturation means. If degree of unsaturation equals 0, it means there are no double bonds or rings at all. You must have simple chains as your molecule structure. If your du equals 1, the structure has either a double bond or a ring. If the du equals 2, it has 2 double bonds, 2 rings, or a ring and a double bond, or a triple bond. Oof, that's a long one. If du equals 3, it means it has 3 double bonds, 3 rings, 2 double bonds and a ring, 2 rings or a double bond, or a triple bond and a double bond, etc., etc. You get the idea, okay?